So to give you a quick preview as to what's happening, we got about 25 minutes where we're going to talk about collaboration between SpectrumX and the broader Spectrum community. And then at 3 o'clock, we are going to do a quick room change here, and we're going to prep this room for a career fair. At 4 o'clock, we're going to have our students gather along with academic, industry, and government representatives to talk about their organizations, do a little bit of mentoring, a little bit of talking about career opportunities and career pathways. So that's going to happen at 4 o'clock during the coffee break, and we'll run after the coffee break as well. So for that reason, we have to get going with this session. So thank you very much to you all that are here today. Wanted to talk a little bit about let me introduce myself first. So my name is Josh Tullis, and I'm the Managing Director for SpectrumX. But I also wear a second hat, which is the Collaboration Director as well. So I'm from Notre Dame, and to take a step back, and this is who SpectrumX is. SpectrumX is a community of 56 researchers and staff and growing. There's 30 different partner institutions and growing, and 82 students and growing. Growing because, let's see, in year 2, we added 4 MSI partner institutions, and in year 3, we have added 3 more partner institutions, including the University of Chicago, Ohio State, and our most recent one was Southern University. And in addition to that, we've added a new model for growing, and I'm going to focus on growing because we want to focus on the collaboration side of things. So the growing part for individuals is this affiliate model where individual academics can join in an unfunded model and be able to be a part of our research community as well. And this is a recent development in year 3 for us. And we have 6 or 8 people that have taken us up on that invitation. And thank you to those folks. And so then the next thing that we want to talk about is our collaborators. And so this is a model. We have collaborators from across the country, and we track a couple of different things. One is that at the proposal stage, we had letters of collaboration from 27 different entities. We also identified 11 Spectrum resources that we are now aggregating thanks to Scott Palo and the facilities group. And then we also have active collaborators that are across the country, and they fit into a couple of different categories. So I wanted to talk for a moment about a couple of ways for government and industry to engage with us. And so this is a quick model of research within SpectrumX. And we have in the black circles, these are different entities and organizations within SpectrumX. There's a research planning committee that works within our center leadership and research leadership that works with seed and flagship. But there's 2 feedback loops that are happening. One is the really large feedback loop where we're looking to engage with government and industry representatives to be able to help inform our research. And then the second upper right feedback loop is our external advisory board that was introduced in the overview yesterday, and then also our collaboration advisory board. So both of those feedback loops are where we are working with the external community to be able to help to inform and influence our research activities. So our SpectrumX collaborators are shown here. We have 9 collaboration advisory board members, and they're in the top: GERD, Qualcomm, IRA Technologies, WinForum, ThinkRF, Cable Labs, Joe Durandal, and DeepSig. And we also have 3 other collaborators that we work with that are outside of the Collaboration Advisory Board, one of them being Google, who has helped to support the Broadband MAPIS project, the NTIA OSM and NTIA ITS both have been supporting through a liaison program. So the liaison model is one way that government agencies can engage with us, and so the upper part of this model is meant to show the complexity of what's happening sort of behind the scenes. And what we want to show is that all of this is already existing at the top. And this is stuff, a machine that the center has built. And we've been able to now replicate that through a liaison model where sort of an easy button where the stuff already exists at the top and you don't have to reinvent that wheel. And this allows then a government agency to be able to much more easily just to spin up new projects. So the example is a couple liaison projects that are happening around 5G, around value-based spectrum management, and AI machine learning for spectrum management with these partners from NTIA OSM and from various spectrum researchers, including Manisha Ghosh that's up here on stage with us, Randy Barry, and Kong Shen. So now sort of drilling down, I'm kind of working my way down to our Collaboration Advisory Board. And so the Collaboration Advisory Board is a membership fee-based model that allows companies to be able to join and then to be able to provide influence and to participate and to provide access in various different activities of the center. So within the influence, we have the ability for creating an environment where we can hear about industry needs, research priorities, and to provide feedback on the work that we're doing or the work that we should be doing. It provides an opportunity through the Collaboration Advisory Board to be able to participate in center activities, to collaborate on projects, to join in our center meetings, and to be able to sponsor or host various students or projects. And then through access, we have the ability to engage industry subject matter experts, to recruit students, to utilize labs and testing facilities through supplementary agreements that we could work on together, and to review various center outputs and products. So with that, what I thought I would do would be to highlight one example of the Collaboration Advisory Board. But first, I wanted to find out if everybody, you have your phone in your pocket. There's we've talked about Wi-Fi calling in here. It's been mentioned before. How many people have relied upon Wi-Fi calling in their day-to-day life? I know in my office back at Notre Dame, there's no cellular coverage, so the Wi-Fi calling really helps out quite a bit. And one of the things that was really interesting is that in this particular screenshot here, you can see that on T-Mobile, I'm not picking on T-Mobile for any particular reason, it's just the image I picked up on the internet, but it shows that the signal is really low. But the Wi-Fi signal on there has all of its various bars. And then in the bottom left, you can see that it's showing that Verizon, there's a separate signal in the top left in the gray image there, showing that you have cellular connectivity through the Wi-Fi to be able to make phone calls. And then on the right, you're able to see you actually have your cellular connection turned off. It's in the airplane mode. And yet you can still have showing that in the image, it's kind of grayed out, so it's hard to see. But T-Mobile has connectivity, so it's connecting through Wi-Fi. Sort of interesting, like there was conversation yesterday that talked about that there was about 80% of traffic was being run through the Wi-Fi signal. So it got me thinking about this, and as to we needed to kind of pull on that string a little bit and to understand a little bit more. So I thought it would be really neat to be able to highlight one of the collaboration relationships that we have, which is with Cable Labs, to find out a little bit more about this, what's going on here. And so with that, I want to introduce the panel that we have here today, and that is thank you to Mark Walker, Vice President of Technology Policy at Cable Labs, and to Dave DeBrecht, the Vice President of Wireless Technologies at Cable Labs. Thank you for your partnership with SpectrumX. And thank you to Manisha Ghosh for being able to represent the interests of SpectrumX up here today. So I thought we would do a spotlight on the relationship between SpectrumX and Cable Labs. So start with asking Cable Labs a question. Can you, Mark or David, can you please tell me a little bit about Cable Labs? Who is your constituency? And kind of maybe start with that. Yeah.
Thank you, Josh. Yes, who is Cable Labs? I imagine, has anybody even heard of Cable Labs in the room? A few, okay. So Cable Labs is the R&D and innovation lab for the global cable broadband industry. We're a membership organization. Our members include names you might be familiar with, like Comcast, Charter, Cox, Vodafone, Rogers, across the globe. And what we do is we basically are a platform to help drive harmonized network technologies to get global scale and scope. So if you get broadband from a cable operator at your home, they use DOCSIS technology to do that, to provide that broadband technology over the HFC network. We are the ones that have developed and maintained that standards and that specification so that the entire industry can benefit from that harmonized technology. So if it were just Comcast buying one-off chipsets for their network, the cost would be orders of magnitude higher. So the industry has come together through Cable Labs to standardize and drive those technologies. So as you think about the evolution of connectivity, as we heard yesterday, Wi-Fi is the workhorse of the internet. So it's one thing to get broadband to your house, but then it gets distributed throughout your house, throughout your enterprise via Wi-Fi. So over the years, Cable Labs, by its name, has sort of focused on wired technologies, but that is truly diversified now. We spend about half of our time, David's team, on wireless technologies, and that is Wi-Fi, but also as we're seeing a convergence of mobile and Wi-Fi technologies, we are also heavily participating in 3GPP to drive those technologies as well. And back to sort of Josh's problem, our ultimate vision is of seamless, ubiquitous connectivity, where the consumer no longer sees, oh, am I on Wi-Fi? Am I on 5G? That is just in the background. And the networks managing those connections, those multiple access networks, and you just get the connectivity you need. That takes a lot of coordination at the network level to do that, to be able to hand off between Wi-Fi and mobile seamlessly. We've all experienced it. Like, you start on a Zoom call in your house, you walk outside, it goes effectively dark for about 10 to 15 seconds until it reassociates. The session moves from the Wi-Fi connection over to the mobile connection. And if you're lucky, it doesn't drop out. Zoom comes back, but there is that sort of lag. And so those are one of the struggles as we think about the convergence of these access networks. How do you truly make them seamless? So our interest in engaging with SpectrumX is really to help bring those sort of challenges that the industry is seeing into the research community, but also seeing the work that you do and how we can then bring that into industry, to the user, to the end consumer. And where you guys are making advancements, how do we sort of bring that into the commercialization pipeline? And we sort of sit between that world. Like, the work we do is definitely not sort of the academic research work. We are sort of much closer to the commercial work, but we are also not the vendor community either. Cable Labs does not make or sell anything. We just help convene the industry, harmonize and drive that common utilization of technologies. We spent a lot of time not only at 3GPP, but at the Wi-Fi Alliance and IEEE to drive those features and functionality that the industry needs. I'll let David clarify, correct anything I've just said, and we'll go from there.
No, good. So yeah, no, completely agree. I guess the way I would put it is, you probably all heard of Bell Labs as the innovation center for the telecom. Cable Labs is the equivalent for the broadband industry. And you've all heard of 3GPP that does the standardization work for mobile networks. Cable Labs did the standardization work for the broadband industry over coax, which is DOCSIS, like Mark said. So we're kind of a combination of both of those, doing that innovation part as well as the standards part for the industry. The only thing that I would add is that a lot of the members that we have, and two of the biggest ones that Mark mentioned, Vodafone and Rogers, Canada, and then in Europe, Liberty Global is another one as well. They're both mobile network operators and broadband fixed operators. And they're really struggling trying to figure out how to bring their networks together, how to have a common network, how to only have to manage one network instead of managing 2 or 3 or 4, because they have optical networks, they have DOCSIS networks, they have mobile networks, they have Wi-Fi networks. So how do we actually bring those all together so they can just actually operate and manage one? And the way we like to put it is we'd like to make the network invisible to the end user. And that's really hard to do. And that's really what we're driving towards doing. As Mark said, probably a good 75% of our work these days is not on cable because we have a very strong team working on optical technologies. We have a very strong team doing wireless, Wi-Fi, mobile, security, you name it, we're working in it, trying to bring those networks together and doing that in between the initial research and the actual industry. So you might call it applied research or industrial research, trying to bring it actually to market. In the panel that I was on yesterday, the last question that was posed was, what would you what would you tell students to look at when they're looking at research? And my answer was, what's the problem you're trying to solve? Because it doesn't do any good to go off and solve a bunch of problems that aren't really problems for the end user being either the end user me or the end user of the industry. You have to figure out what problems are out there and try to solve the problems that are real to bring things to market and to work together.
Thank you. Manisha, thank you so much for joining us in a busy Spectrum Week schedule for you. Could you tell us a little bit about what it means to you and perhaps more broadly for the center to have a team like Cable Labs be a collaborator of ours?
Yeah, sure, Josh. Thanks for that. I think what you said, David, is really what academics and students and professors need to hear, are the real-world problems. So I think we are really good at coming up with nice solutions, but many times we need a little bit of collaboration in trying to really nail down the problems. And I think this conference has been extremely nice in that sense, which is, I think, different from some of the other IEEE conferences that I've been to, where we've really heard a diversity of opinion as to all of the challenges that we face in Spectrum, and all of the different stakeholders and what their viewpoints are. And Cable Labs brings in a certain viewpoint of what their needs are and how they see the spectrum that is being evaluated, how it could be evaluated. And we also have other members in the collaboration group that have maybe similar or conflicting ideas. So I think having more companies like Cable Labs and others that can bring in their perspective on how SpectrumX can stay true to its name and really figure out how to make the best use of spectrum going forward with either measurements, technologies, analyses, policy developments. I really appreciate the fact that Cable Labs has decided to join SpectrumX.
Yes, thank you. So I think a question for David. We've heard about some programs within SpectrumX, like the Broadband Mappus project, and which has the Signal Hound app. We also have the Radio Hound Spectrum Analyzer. Can you tell us a little bit about some of the measurement work that Cable Labs is interested in, and how does that perhaps connect with SpectrumX?
Yeah, for sure. So we have a project ongoing right now doing exactly that, doing measurements and trying to understand, because at the moment, you look at the FCC spectrum board and you just see big blocks of spectrum, saying this belongs to this person and this, there's 3 tiers of spectrum use here, and you really don't know who's using what, when, where, and how, because nobody does. Nobody tells you what they're doing with it. You just got a block of spectrum. Are you doing anything with it or are you not? We've actually developed a relatively inexpensive, and we're working on making it even more inexpensive, recording device that goes off and just measures energy in the band. Is there somebody doing something in this band over a wide frequency range, so that you can look at, I can't remember right off the top of my head, it goes down like a gigahertz or maybe a sub-gigahertz, all the way up to right now 8, if I remember right, and we're looking to do it up to 12 or 14, so that you can go measure what's really going on. And so far, I think we have 3 or 4 placed right now in different parts of the country. We're hoping to expand that into major areas, because it's very, you need a lot of data from a lot of different places to make it make sense. The whole point being that once you get that data, you need to do something with it, kind of like the data panel yesterday. It's great to have a lot of data, but you need to do something with it. You need to know what the signals are doing, where they're coming from, is there energy in the band, et cetera, et cetera. So bottom line is, all that data gets pumped into a common database, and from that common database, you can pull out of it and show nice graphs and charts saying, okay, here's a band that's allocated to person X, but there's nobody using it. And we're doing it over a 24-hour period, do it over multiple locations, and things like that to really understand the use of the spectrum, and I think that's key, so that we can actually get more spectrum in use in the different parts of the country where we need it.
I would just add to that, particularly as we think about sort of, 3.1 is obviously, a major band that sort of the U.S. is considering. And, oftentimes the discussion is focused on coexistence. Do the technologies coexist or not? Well, that's only half of the equation. The other half of the equation, is there actually space for a commercial service to live in that band in an economically viable way? It's one thing like, okay, we can design a technology where the radar and the IMT or whatever technology can coexist. But how much space is there in time, frequency, and geography to make the economics actually work? And, our friends at DoD, that is not their concern. Just full stop. They don't really care if it's commercially viable. But if we ever get to a point where we're going to do a shared mechanism like this, and there's going to be an FCC auction, the commercial market needs to understand how much space am I getting for this license? And those questions are just not known. And, it's one thing to say, oh, yeah, you can get that spectrum in the middle of Kansas 100% of the time. There's nobody there. It has no value to the commercial market. It matters where people are, and it matters the amount of time, frequency, and geography that will be available for commercial use. So that part of the equation, I think industry just needs to push on it harder, because without that information, it could be a road to nowhere.
Can I add to that quickly, or need to wait?
No, sure. Let me, do we have a microphone that we can share? Yeah.
Yeah, I want to add something to that. One is get a circle out of that. Actually, I'm from Idaho National Laboratory, and I think this actually, ties very well with the NTIA's National Spectrum Strategy implementation. Because, for example, if you look at, we're talking about, 7 to 8 gigahertz is one of the identified bands that will be analyzed to see whether more of that can be freed up for sharing, right? So we did a paper in the first workshop because DOE actually funded us to do some studies. So we see that there are close to 2,000 allocations to DOE in that band, right, 7 to 8. Now the question is, and that goes back to both of you, observing the uses of it, right? Allocation is one thing, but uses. Now, we also have a good understanding of what these links are used for. We have to go dig a little deeper, but I think most of them are actually really fixed links, and there are some satellite links also. The question is that, that is information that can be derived from the database, and we can provide you with the right permission from DOE and NTIA. But the thing is that a critical piece is what they are allocated for, not necessarily that when you are looking at it, it's being used, right? For example, if you look at a fixed link, for a utility, they may not be transmitting data all the time, right? However, it is there, they need it. And then it can be a emergency actually link, right? So that may not be their main method of communication, but it is there for critical infrastructure use. So I think that we need to collaborate, kind of bring data all in, because I think that's an important piece of data that's there on the government side that you can benefit from and researchers can benefit from, right, Melissa?
Yep, I
Yeah.
think all of these new bands that are part of the national spectrum strategy, we need a combination of sensing, trying to figure out what's in there, information, wherever we can get it from as to who's in the band, and then try to figure out whether we share, how much there is to share, where we can share. Yep,
And in addition, how to share.
how to share.
Because there's like the CBRS, there's definitely a need for doing that, because there are some times when DoD or someone else, I need that band, everybody get out of it. And there are some use cases that we can make work within the industry and within business with that kind of a sharing. But then there are other ways to share. You can co-locate and actually indoor-outdoor, low power, high power. There's no problem with using, for example, very low power or low power indoor kind of solutions in the 7 gigahertz band, for example, if you're only doing it inside of a house, because there's no reason that you can't also use that spectrum outside of the house. So we need to have different sharing mechanisms depending on what the use is and who's using it and who is actually needing to share it.
Please.
Hello, everybody. I'm probably about to ask a very stupid question because I'm still new to this. I guess from the private side or the commercial profit side, at some point, somebody, say like Comcast or some other private company may feel like the knowledge is kind of infringing upon their, I guess, ability to make a profit. So I guess how do you guys address that with those companies? Or you guys feel like that's not really an issue at this point?
Maybe you can clarify, by knowledge, what do you mean?
Meaning, I'm thinking in our case, Monisha, everybody's in a race to, 5G and 6G, right? And who's ever to deploy that the quickest, right, profits the most. Am I correct in that? Or
Possibly.
so that's the kind of issue that, right?
So like actual deployment information, like exactly where they're putting cells and stuff like that.
Right,
Some of
right,
that is definitely
right. If the
proprietary.
information gets out there too fast, right, they may feel like they may lose some of their profit when they've invested in, had some investment in actually deploying that.
There's always definitely some sensitivity around commercial plans, particularly forward-looking plans, like where network operators are looking to make sort of actual deployments. That tends to be somewhat sensitive, particularly before they do it. Obviously once it's deployed, Monisha and her sensors can see exactly where every cell is. But often what's more sensitive is like, this is how we're going to roll out forward-looking. So that tends to be pretty closely held.
And just to add on to what you said, right, like, I think just knowing this can help you. So you gave the example of maybe you have 100 megahertz available in Kansas, and maybe there is no business model that somebody can make money out of using that 100 megahertz in Kansas because there are fewer people, but perhaps the community could deploy their own network at low cost and give them the access to that spectrum so that they can serve their needs. But even knowing this is a lot of value of understanding where the spectrum is available, where it's valuable for from a business point of view, and where it isn't, to make it available to communities. And that to me, I think, was the really nice way that CBRS dealt with it, right? That the access to spectrum was very low and people could just buy equipment. They didn't have to worry about even getting access to spectrum. Because when we're looking at some of these new bands, the early work about trying to find out where it's being used, where does it make sense to deploy commercial systems, where is it available available, but the commercial entities aren't interested. Let's maybe give it to schools or communities to do things.
So can I build on that? Because I took your question a different way. Like, who, businesses and industry and corporations, right? They're centering something different and have a different outcome that they want than like researchers and policymakers and government, right? And like I would center equity and end user. How do we get everybody access to whatever they need, right? Businesses might center money and, right, profit and proprietary kind of things. Who's making sure that we're centering the right thing, or who's driving that? I mean, that's kind of how I took your question, right? Like, we have different missions, right? You are in between the researcher. I would call you research to practice, right? You're taking the research, putting it out there for other people to practice, right? And building that, right? Are you, how do you center the different needs of the different groups, right? Businesses want money and profits, right? Owning things, right? And researchers might have different goals. I mean, not that we don't want grant money and things like that, right? But, right, we just came out of a session about digital divide and access and affordability. And that's not in line with profit and money, right? So that's how I took your question.
No.
Maybe I'm wrong.
I guess I'd push back a little bit that like that's the ultimate job of policy is to align those incentives. Create the incentives to put the market towards those public goods. Like that is foundationally what public policy is about. If you try to fight those incentives or create incentives that are against those goals, you will never get the outcomes you want. We see that every day where the market's failing. But yeah, that's sort of the ultimate issue. But going back to sort of Anisha's point, I agree, that was the amazing part of CBRS, that sort of use it or share it notion. And then when you think about unlicensed, that's sort of the ultimate. It's like, there is no barrier to using it, except, you gotta follow the rules, whatever, part 15 or whatever they are, but anybody can use it. And to take sort of spectrum access away as a barrier of innovation and deployment, instead of in the hands of the few, in the hands of the many. Like that democratization of spectrum is really how we'll unleash innovation. You don't want spectrum access to be that barrier. And that's where, I think notions like CBRS, the great experiment of CBRS and unlicensed, like the innovative community around unlicensed is amazing. Like that is the great American story, Wi-Fi. So yeah, I sort of mixed two different things there, but I hopefully.
Just to maybe hit on the business aspects just a little bit. When we get to the stage of the FCC or the policy, that is where things get tricky, because you have people like the Verizons and the AT&Ts and the T-Mobiles that want that spectrum for high power use for their purposes. That's basically going to impinge on the broadband industry. They're deploying FWA today. That's trying to take away business from the broadband industry that's bringing broadband to the home, right? So yeah, when you start thinking about how fast do you talk about and say, this is my business case that I want to use, it does get a little sensitive. And so everybody's got their own perspective on why they want to use that spectrum and how they want to use that spectrum. And they don't always want to tell you exactly what they want to do with it, because there are business implications.
And I think, just as SpectrumX, I think what we're trying to do here is sort of distance ourselves a little bit from the business models and focus on what we can do from the technology side, understanding the spectrum side, and bringing those learnings into the policy space, so that when somebody is looking at a piece of spectrum and saying, okay, what do we do with it? SpectrumX can say, hey, we made these measurements and we know exactly what is being used where. And then the final decision is lobbyists and politicians, and there are many other things that are beyond our control, which we will not be able to control, right? But what we can do is, talk to collaborators like Cable Labs and, all of the other collaborators we have in the center, and understand what they are doing already and how we can help them, how they can help us, because this is one of the things that I feel is, and so for example, if you develop a way of measuring signals and you can bring the cost down and you can share it with all of the members in the community, or get involved with our flagship projects as we are rolling them out. And that is the kind of, I think, feedback that is really helpful in these collaboration models.
So, yeah, no, I think I completely agree. But I think, let me, maybe I'm looking at it being simplistic, but I mean, we are blaming Verizon and all, right, for buying up. But I mean, I don't think they are to be blamed, because that's created for them, right? I mean, again, I don't want to blame FCC, but assume that FCC did not have these licensing auctions, right? So tomorrow they don't say that, hey, we're going to license it, but we are going to do it in a different model, like public access or local access that UK OFCOM said. I mean, I did not get to ask the question there, but outside I did ask him that local access licenses for private 5G license operation cost about $500.
Yeah.
So I mean, I think it's really the government, right, that decides how what is the process for making this spectrum available, and that will change the whole thing. I really, I think, again, it may be very simple, but that's what is the driver. I mean, Verizon and all, they didn't go to millimeter wave because they want to, but because 5G, that was the only license that was auctioned to begin with. So, what do you think?
I'm sorry, it is a double-edged sword. As an example, I don't even know what year it was, 20 years ago or more, the government said, hey, we think that you need spectrum for education and broadcast. So they set aside 200 megahertz of the EBS BRS spectrum in the 2.5 band. It sat there for decades. Nobody did anything with it. Very minimal use, until they finally said, oh, okay, let's go sell this to X. And then the industry got a hold of it, and now it's the primary band that T-Mobile's using for some of their services. So just an example of, we need to make sure we're aligning the need with the availability, and I think SpectrumX can help do that. What is a real need, and how do we use it?
Yeah, I don't think, I'm pretty sure we all agree. We want our cellular, we want our Wi-Fi, we want our Bluetooth, we want it all, right? We can't say that any one technology can or even should try to satisfy all these needs. The challenge is, a limited part of spectrum, how do you divvy it up? And that is where I think the studies and the measurements and the collaborations help us a lot in trying to figure out, and we have the passive users of spectrum too, so not trying to make a priori decisions about what this band is best used for, but trying to really understand the science behind who is using it, how they're using it, how can we share.
So with that, I think we need to wrap up this session. I would like to say thank you to David and Mark for your participation on the panel today, but also for your partnership with SpectrumX. It's very valuable. This is an excellent example of collaboration at its finest. If you're interested in collaborating with us, we are open for business. We'd love to see you. Thank you.